Okay, the next thing I'd like to teach you now is to calculate this thing called RF value. Okay, calculate RF value. What is RF value? I'm going to quickly run through. Okay, I'm going to write it on the left-hand side of the screen. RF value. What is RF value? RF value is the ratio between the distance moved by the substance. Okay, let's say I want to calculate the RF value of the blue ink. Okay, ratio of the distance moved by the substance. Okay, so the distance moved by the substance, I'm going to label it as ds, B, substance, and the distance moved by the solvent. Okay, this is the distance moved by the solvent. I'm going to label it as DSOLV, distance moved by the solvent. So what is RF value? We calculate RF value by is the ratio of the distance moved by the substance over the distance moved by the solvent. Okay, and that's what the RF value is if I were to ever ask you to calculate the RF value. Okay, so if you think about it, if a substance has high solubility, would the RF value be high or would it be low? Okay, let's have a think. Okay, maybe we can have a think also. Let's compare it to the red ink. Okay, this is the distance traveled by the red ink, right? If a substance has high solubility, will the RF value be high or low? If a substance has low solubility, will the RF value be high or low? Okay, I'll pause a while, I'll let you think about it. Okay, so let's think. Let's say the distance traveled by the solvent front is 10 cm. Let's say the distance traveled by the blue ink is maybe 8 cm. Distance traveled by the red ink is maybe 5 cm. Okay, if we do the math, 5 divided by 10, okay, for the red ink, let's say the RF value of the red ink is 5 divided by 10, this is 0.5. What's the RF value of the blue ink? Is 8 divided by 10, and I get 0.8. And so you see, the higher the solubility of a substance, the higher the RF value. The lower the solubility of the substance, the lower the RF value. Okay, so the closer the substance is to the number 1, okay, the closer it is to 1, because if the ink droplet travels at the same rate as the solvent front, imagine it's 10 over 10, then it's going to become 1. Okay, so the closer the RF value is to 1, the higher the solubility of the substance. Okay, so this is what RF value is for. RF value helps you to gives you an indication of how soluble a particular substance is. And the RF value of a particular substance doesn't change regardless of whether you carry out the same experiment over and over and over again. It won't change if you keep the conditions the same. Right, so this is one way I can tell what kind of substance it is by comparing it to already known RF values that people have calculated before. Okay, so that's a little bit about chromatography. Okay, so how we use chromatography? Chromatography involves the use of a solvent. Okay, why do we use a solvent? Because we are going on the basis that certain substances have each substance has different amount of solubility. Some have very high solubility, like this blue ink over here. Some have very low solubility, and we are leveraging on the difference in solubility in a solvent to help separate out substances. Okay, that is how we use chromatography. Do we only use chromatography to separate ink, right, as the name suggests, color and writing? Do we only use it to separate ink? Not really. We can use chromatography to separate out many other things. As long as the thing can dissolve in a solvent. Right? I give you an example. There are other things that you can separate out through chromatography. For example, next time you learn there's a thing in the body called amino acids. Amino acids are what we use to build proteins in your body. Amino acids can also dissolve in a solvent, and different amino acids have different solubility. So once again, as long as the substance can dissolve, is soluble in a solvent, and if these substances have different solubilities, then I can use chromatography to separate them out, because we know that things that are more soluble will travel faster along the filter paper along with the solvent. Things that are less soluble will travel slower on the filter paper along with the solvent. Okay, so that is all I'm going to share about chromatography. I hope this has been useful to you, and we'll see you in the next video.